Hello. This video series aims to explain the mechanisms of the profile aligner. But before we get into the novelties of the profile aligner, it is important to understand the foundations. Specifically, we'll be talking about the Gotoh's alignment algorithm that utilizes this dynamic programming approach. And we'll be following an example to understand the mechanisms. So over here we have sequences A and B. And intuitively, there's two ways to align these sequences. So in the first one, we can have a single gap with a length of 2. In the second alignment, we can have two gaps with a length of 1. Now, based on the principles of genomic stability, it is better to have a single continuous sequence over multiple short sequences. In other words, the alignment that minimizes the number of gaps would be more favorable in terms of evolution. So we need a way to tell the algorithm to prefer alignment 1 over alignment 2. And Gotoh's algorithm does this by implementing an affine gap penalty, which looks as follows. So this is the gap penalty, and we have a linear equation where k refers to the number of bases that are in gap. Bases. V is the cost of inserting the gap, whereas U is the cost of extending the gap. And the way this algorithm would work is by setting the gap insertion cost to be greater than gap extension cost. Now these two parameters are subject to optimization, but for the purposes of this video, we'll set the parameter u to be equal to 2 and parameter v to be equal to 5. Now let's calculate the gap penalties for each alignment. In the first alignment, we have a single gap, and there are a total of 2 bases that are in gap. So we are looking for g of 2. And this would be 2 times 2 plus 5. So now we have the gap penalty for alignment 1 is 9. In the second alignment, we have 2 gaps. So for gap number 1, which has a length of 1, we have 2 times 1 plus 5. So over here we are looking at this gap. And then we have a second gap, which also has a length of 1. And it would be 2 times 1 plus 5. And the total gap penalty would be the sum of these 2 gap penalties, so 14. So as we can see here, alignment 1 has a gap penalty of 9, and alignment 2 has a gap penalty of 14. And this is a way we would tell the algorithm to prefer alignment 1 over the second. In the next video, we'll implement the Gotoh's alignment algorithm.